a solutions architect on the AWS platform, right? These different concepts all tie together. Everything that we've been speaking about, none of them are really isolated. All of them just work hand in hand to ensure that we have a full understanding of how to, draw up architectures in AWS, how to design architectures, that would be the better word, in AWS that function in a very performant way, that are secure, that are optimized, that reduce cost, and all the likes, right? And we would also discuss something we call the AWS well-architected framework closer to the end of today's session, so that would even just tie up all the knowledge that we have. So this course is more about, this particular module is more about you just having those concepts, being able to visualize them, understand how they can be followed or, practiced on the AWS platform. And we have the last kind of sub-module today, right? Where we'll be talking about scalability and high availability and some other things related to that. So we'll just dive right in to scalability. So the topic of scalability. So you might have heard of this before in some other system, or some other software, right? Scalability just speaks to the ability to scale. The ability to scale, the ability to grow, or the ability to shrink, right? You think about it when someone says, I want to scale my business, right? Really, we always think to grow, to increase, but you have to ask the question, do you want to scale your business up, or do you want to scale your business down, right? Because when you scale, you can either get bigger or you can get smaller, right? So scalability is the ability of a system or an application to grow and manage increased demand seamlessly, right? So you can think of your favorite restaurant. When you go there, and maybe they're running out of tables, right? Maybe it's just a busy night. The ability of the restaurant to add more tables so that they can serve more customers based on the increased demand means that that restaurant is able to scale, right? So scalability just speaks of recognizing demand and adapting to that demand, adapting the amount of resources you have on AWS to that demand, right? So in the case of AWS specifically and AWS services, one of the more practical services we can use to explain scalability is the EC2s, right? So you can scale EC2s, when you need more. Let's say before you had like 100 requests per minute, right? But for some reason you are doing Black Friday, right? And there's more traffic coming in. You have 50% off on that site that you're managing as a DevOps engineer, right? There'll be more demand, so you need to be able to scale those EC2s, right? So you can scale them in different ways, which is what we're going to talk about now. So we have two kinds of scaling. We have vertical scalability, we have horizontal scalability, right? Vertical and horizontal. So the vertical scalability involves adding more power to your already existing machine, right? And by power, I mean CPU and RAM, right? Or maybe even storage, right? Let's say you are running a 2-core, 2 GB RAM machine, and you predict that you would have more traffic due to your Black Friday sales, or you predict that, I mean, even if you don't predict, let's say more traffic just comes in and your servers are getting overwhelmed, you can quickly increase the capacity of that machine. That means you are scaling that machine vertically. So it's vertical because the machine is the same machine, so it kind of grows bigger. You can think of it as like growing taller because you are adding more capacity to it, right? So that's why they are scaling vertically, right? Such scaling, the vertical scalability, this kind of scaling is it involves downtime, because whenever you need to scale in terms of changing, adding more CPU, adding more RAM, most times there will be a little downtime. Maybe it might need a reboot or something like that, especially when you're adding storage also, depending on how you add it. So it can involve downtime, depends on how you're scaling it, right? So it's not necessarily the best form of scalability, but it just depends on your use case. Maybe you are the kind of business that is fine without downtime. Maybe you can predict it. And let's say off-peak hours, you just decide, you see that you don't have any much traffic, you're able to shut down and quickly scale the server up and prepare for the incoming traffic that you might have. So that can work for you. It depends, right? But it's not something that many applications use these days, to be honest, right? So we also have the horizontal scalability. This one is also referred to as elasticity, right? So horizontal scalability means adding more machines to your application rather than adding more power to the existing machine. So if you had one EC2, let's say if you are adding two more or even just one more, you are scaling horizontally, because you have to think about it like this now. Let's say you had one EC2 just maybe sitting on the table. If you are adding more by the side, horizontally is getting longer, like you have more EC2. So that's the idea when they say horizontal scalability, right? So you're adding more machines. It's similar to the restaurant analogy I gave, adding more tables. So you're scaling horizontally in that case. In the restaurant scenario, if you are scaling vertically, you just make that table, you exchange that table for a bigger table that can just have more customers on the table, right? So in AWS, you can scale things like EC2s, even RDS instances. You can scale them horizontally because you can add more instances, right? Then you can use services like load balancing to distribute the traffic or the load across those instances. We'll talk about load balancing in one of our slides, but just to give you an idea of how that works, because you might be thinking about it that, oh yeah, so when I scale horizontally, doesn't the traffic, kind of, or the data stored, doesn't it become different because it's not one machine, right? Data is stored on different kind of machines, right? So there are ways you set up your architecture to ensure that that doesn't happen, right? Usually it's something you set it up in a way that is referred to as being stateless. That means it doesn't store any unique data on any machine, so it still stores it in a central place. So those machines, if you just decide to shut down one, bring another one up, it doesn't really matter. The machines are pre-configured in a way that they can work for that scenario and they don't need to store any data on it, right? So the two types we have basically are horizontal scalability and vertical scalability. So if you are maybe doing your exam or working, and someone brings up a scenario and they say, oh, we are expecting high traffic at so time, right, due to some sort of events or whatever, and we cannot afford downtime. So if you hear a question speaking of how we cannot afford downtime, your mind should immediately come to horizontal scalability because it doesn't involve downtime. The existing instances are there. but you're just adding more instances to it, right? So if it's a situation that they're saying, we can afford downtime, but I mean, we don't really want to add more servers. We just want a more powerful server. You're thinking of vertical scalability. So yeah, that's really just how those concepts work, right? So scalability is linked to high availability, but is different. We'll talk about high availability in more depth, right? Scalability ensures that the system can accommodate growth, while high availability ensures that the system is always operational, that it minimizes downtime even during failures, right? So high availability is speaking more of availability, really. Like, oh, if something goes wrong on one of the servers, can the others cover up, right? While scalability is thinking, if more traffic comes in, can we meet the demand of that traffic, right? So all this I'm saying in terms of scalability is very critical within the DevOps culture, especially for continuous delivery and deployment, right? Systems must be able to handle additional load from new features or users without having any form of performance degradation, right? So you might have deployed a new feature that might bring new users. You have to be able to handle that additional load that will be coming in, right? And one thing to also keep in mind is scalability is not just about handling growth. It's not just about growing. It's about being cost effective, right? Because, if you think about it, if, for instance, you start to have what we call spikes in traffic on your website, right? The website you're managing, the company website, or the company's banking application or whatever. If you're having spikes in traffic, let's say, at so time, let's say at 10 a.m. from 10 to 12 p.m., 10 a.m. to 12 p.m., you always have like 10 times more traffic than usual, right? Then from 2 p.m. to 5 p.m., you always have 20 times more traffic than usual. But all other times you have like usual traffic. So one of the suggestions that might come on the table is let's just scale this vertically to something that can handle 20 times, since that's the largest amount of traffic we expect. So that would work. But if you think about that now, even at the moment where you are having normal traffic, you would have overspec your server. That means your server will be having so much resources that are unused, right? Even at the time when you're having 10x more traffic, you'd have overspec your server too. It's only at times you're having 20x more traffic that you're actually using, efficiently, using the server efficiently. So scalability, the ability to scale up and to scale down, ensures that you can increase when you need to, and you can decrease when you need to. That means if you're not having as much traffic, you can also decrease, right? And we'll talk about this in more depth, because there's an automatic way of doing that. You don't have to do it manually, right? But we'll speak about that in a few slides. So one of the other topics we spoke about in the last slide was high availability, right? High availability is related to scalability, but it's a bit different. So in cloud computing, high availability is like so okay, think about this situation now, where you have multiple power generators, right, in your company. If you've ever maybe worked in a data center, or maybe had anything to do with a data center, or even like the big companies, they hardly have one power source, right? They usually have multiple power sources just to ensure there's no failure, right? So if you have like multiple power generators, and if one fails, the other one can take over automatically, like can switch over automatically without the lights going off, right? Which ensures that operation continues. So that is high availability. the ability to for your infrastructure to continue operation despite a failure, right? It means that it's highly available. So even if a failure happens on one of your EC2 instances, another one, is available to pick up, right? So high availability often involves horizontal scaling. So it distributes your applications across multiple servers to avoid a single point of failure. So when you're thinking of high availability, you're not thinking of a single server. Of course, you're thinking of multiple servers, because once you have a single server and that's all you're working with, you have a single point of failure. If anything goes wrong with that, everything is gone, right? And when you're thinking of high availability, one of the most important things to think about is availability zones. I know we talked about that a few classes ago, availability zones. Just to remind you, availability zones are data centers within an AWS region, different data centers, unique data centers that have their own power, their own cooling, their own everything, right? It's separate. It's not linked to any other availability center. Like the power source is different from the other data center. So if something happens to the power source of availability zone A, it's not going to affect availability zone B, right? But they are all in the same region, right? So just think about it. If the region was Nigeria, you would have one availability zone maybe in Lagos, one in Abuja. So if something goes on with Lagos, goes wrong, Abuja can pick up. So in high availability, it means running your applications across at least two availability zones, two data centers, because you have that kind of insurance that if something goes wrong with one, another one would be able to, handle the load automatically, right? And it's only a switchover of traffic because that one was the second one was already running. It's not like it's just gonna spin up. It's already running. So it's just there in case something happens to the first one, right? So it ensures that the primary goal of availability is to endure even if an entire data center goes down, because that happens in AWS, right? It doesn't happen frequently, but it's possible. So you have to plan against that, right? That sort of thing happens maybe once every 10 years or something like that, right? So when you're thinking about high availability zone, you can think about having multiple servers, multiple AZs. For databases, you can think about having multiple not data centers, multiple databases across multiple availability zones, and you would implement a sort of replication between them, and you implement failover mechanisms, right, to ensure that if anything happens, one fails over to the other. The master or the slave becomes the master if the master goes down, right? That kind of thing. But we'll talk about databases too, because AWS has its RDS service, right? Relational database service, which already does that automatically. If you are using that service, it has the ability to deploy across multiple availability zones. But we'll talk about that, as we proceed. Right. So availability is very, very critical in DevOps. Very critical, because you want to ensure that your systems are always up and responsive. As beautiful as your application may be or your infrastructure may be, if it's not accessible to your users, then it's as well as useless, right, at any point. Because for high performing companies, if when you think about like the banking center, you think about your Amazons or even your Jumias, or like if their sites are not available for even 10 minutes or so, they lose a lot of money. So high availability is a very, very important concept to understand and to ensure that you implement in any sort of infrastructure architecture that you are building, right? One other thing that really helps, which I do, like we do in my company where I work, is doing regular testing. So you simulate failures, right? They are called game days, where you simulate failure of a particular availability zone by just shutting down the server and seeing if your architecture supports availability, if your traffic, if your traffic is still up, like if your servers are still, if the traffic coming to your site is still being responded to, or if you have an outage because of that, right? So you can simulate it before an actual event happens, so that you are sure that, it's the same way you do a fire drill at the office, right? And someone will just, come and be like, oh yeah, they just ring the fire alarm and everybody has to follow the procedure and all that, similar, right? But this time you are testing for high availability. So you just want to make sure that your infrastructure is resilient at every level, right? So these are just some examples of what vertical scaling, horizontal scaling looks like, right? So vertical scaling, like I mentioned, it looks like you moving from a T2 nano to a U12 TB1 metal. I mean, that's a very big jump, going from 0.5 gigs to 12.3 TB, right? You can also think of it like going from a T2 nano to a T2 small, right? 0.5 GB of RAM to 2 GB of RAM. That's a scale up, right, vertically. So if you are moving back from T2 small to T2 nano, that's a scale down from 2 GB RAM back to 0.5 GB RAM, right? So horizontal scaling, like I mentioned, just speaks about the increase in the number of instances, right, across board. So that involves things like auto scaling groups and load balancers, right? I know we've not touched on the two yet, but we have them in upcoming slides and we'll speak about them much more deeply, right? So, and just to recap, for high availability, is just speaking about running the same application across multiple availability zones. So I would just pause here to take questions on what we've talked about. We've talked about scaling and high availability. So do we have any questions regarding anything I've said, the concept, or any comment or any feedback? Is it something that makes sense? Are you understanding this concept as we are moving along? Or maybe have you seen it before? Have you seen it somewhere and you didn't know that this is what it was called? Sometimes you see some things, but you never know what their name is until it's explained. So I'd love to get your questions if you have any, or feedback before we move on to the next thing we have to talk about. So if you have a question or a comment, please just raise your hand and I'll give you the ability to unmute your mic. All right, we have Bolaji. Do we have any other people? Bolaji, I'll mute you in a moment. But just want to see if we have any other people. I'll take like 3 of us. Okay, let's just start with Bolaji. Maybe other people have questions as we speak. You can unmute your mic now, Bolaji.
All right, thank you. From what you just said now, so I just like a confirmation of, so that I don't go with a wrong impression. Does it mean that for vertical scaling, you are tweaking the resources? Then for horizontal scaling, you are tweaking the infrastructure. Like you are increasing or decreasing the servers. Thank you.
Yes. Thank you so much for that question. Yeah, maybe it's just the wording. For horizontal scaling, yes. Sorry, for vertical scaling, you're tweaking the resources in that you are increasing or decreasing how much resources the same server has. For horizontal scaling, however, you are adding new instances, adding new servers, right? And if that's what you mean by tweaking the infrastructure, then you are spot on, right? you're just adding new servers. So rather than just still having, to be honest, in vertical scaling, it's not always that you have one server. You might have 5 servers, but you are only scaling them up by increasing the resources of each of them. So each of them are 2 GB RAM, but you've decided to scale them up by having them to go to 4 GB RAM or 8 GB RAM. In that moment, right, you are doing vertical scaling. But if you're scaling, will I say, tactic now, or scaling configuration is to add more servers, if there's more traffic, then you are doing horizontal scaling. So I hope that clears things out. Bolaji.
Yes, thank you so much. Yeah.
All right, you're welcome. Thanks for that question. Okay, so I will take 1 or 2 more questions just so we have time to cover the remaining parts of the slide. So please just or comments, whichever one, or confirmations like Bolaji just had. Just raise your hand and I would allow you unmute. Every question is welcome. I mean, no question is a stupid question. The only stupid question, actually, there's no stupid question. Even if you don't ask it, the challenge is just that you go home without getting clarification, which is not nice. But sometimes the question you want to ask is the question everybody wants to ask, but everybody's afraid to ask for some reason. So if you do have a question, please let me know. I'd love to speak on it. Yes, Stereo. Go on, please.
Hello, good evening.
Good evening, Stereo.
All right. So actually, I missed the last class, and
Okay.
I've not caught up to until now. So
Okay.
actually, for me, it's the slides. We've not been able to get access to the slides.
Oh, really? Okay.
Yes.
Okay.
So
Okay, that's
I
fine.
don't know. Like, can that be made possible? So that
Absolutely.
so that we can actually have something to catch up with properly.
Yes, yes. That will be made available. Samuel, please, let's take note of that. For the slides, please let's make that available. Or if it's already available, you can just point Cyril to where he can get it. Right?
Oh, thank you.
Samuel, all right, you're welcome. Samuel, just to confirm that you're there, can you let me know if that will be done, just to give them some confidence also that that's been done. Okay, I'm sure someone has taken that down, but you can also put it in the chat just to let them know that we'll take care of that. I mean, yeah, the slides are really, they'll definitely be helpful for you, and they're for you. Okay, it's noted. Thank you so much. So someone says it's noted, and that feedback will be actioned appropriately. All right, so cool. I think we'll just forge ahead. So make best use of our time. If you do have any questions as we move along, please place it in the chat and I'll speak to them. All right, so we've been intermittently talking about load balancing in the different slides. And we've been talking talking about, just because they are all intertwined. So it's quite hard to speak about one and not speak about the other, because they kind of enable each other. They work together with each other to ensure that the concept as a whole works properly. Because if you have scalability without load balancing, it's kind of useless, because you just have multiple servers that are almost clones of each other, and you don't have a way to link all that to one single site. So load balancing is what enables those multiple servers to receive or to respond to requests from like a single endpoint, like a single web page or a single domain name or IP address, whichever one, right? So load balancers are servers that forward traffic to multiple servers. That's a very simple definition of it, right? So you can imagine a load balancer as a call center, right? You have this customer care call center. And usually when you put your calls through, there are multiple customer care representatives at the back end. So there is some system that ensures that your call is going to customer care representative A, the next person call is going to B, and so on and so forth. So it basically just distributes those calls, right? It directs incoming calls to various customer service representative to prevent long queues of customer calls and to just ensure that there's a smooth experience for the customers, right? So you can think of the calls as web requests, and you can think of the customer care representatives as the servers, right? So the people making those calls are the users. So the users make the calls, which are the web requests, and the load balancer, in this case, which would be the call center, just directs the incoming calls to various representatives, right? So as the name implies, load balancing the load that is coming in across multiple servers on the back end, right? Yeah, so it could be network or application traffic that is being balanced or distributed across the number of servers you have at the back end. So benefits of using a load balancer, right? So a load balancer ensures that you have reliability and availability of your applications, right? By rerouting your live traffic from one server to another if one of the servers becomes unavailable or if one of the servers is under heavy load, right? So the way load balancing works, there are different ways you can configure it, but if there's one server that becomes unavailable for some reason, traffic would not be sent to that server anymore. It's very smart. The load balancer service, it's quite smart. It does something called a health check, right? So it checks the health of that service. It's doing that maybe every 30 seconds or even less, right? Just checking, oh, is this server still healthy? Is it still healthy? So if at any point it's unhealthy, something has gone wrong with it, it will stop sending traffic to that server and send traffic to another server, right? And it also works with something called auto scaling, which would automatically, it's like scaling that we talked about, but happens automatically. It automatically replace that server with something else, right? So, but we'll talk about that in the next few slides, right? So one of the benefits is just that reliability and availability, because your site is never going to go down, or maybe, let me not say never, but has a very, very small chance of going down if you are load balancing your traffic across multiple EC2 instances or multiple servers at the back end, right? So it's in the call center analogies, it's just like, I mean, it's similar to how, the call center ensures that no single customer service representative is overwhelmed with calls, because it's just allocating the calls equally amongst them, right? No one person is expected to make, 10 calls in 10 minutes, right? They will ensure that each of them have enough time to make their calls because they have a fair number of people in the call center, right? So AWS offers what is called an elastic load balancing service, right? This does the work of load balancing. It automatically distributes incoming application traffic across multiple targets. The targets are usually EC2 instances, but they can be different targets, but usually EC2 instances, right? And like I mentioned, the load balancers perform health checks, right? The health check might be, a certain URI or a certain path on the website. It might just be www.wisdom.com/health check. That might be the health check site. So it can just be configured like that, and you configure it on the load balancer just to show, just so the load balancer can know where to check that is a server is healthy, right? So if you say, oh, when you check this, do this health check, the response you should get from the health check is a 200 response, HTTP, right? A 200. And if the response that comes is like 201 or something else, 500, it will determine it on healthy, right? So it's just like the load balancer expecting to say hello to your servers, and your server is supposed to say hello back. But if your server says anything other than hello, it just believes that it's unhealthy, right? So that's a basic way to think about the health checks. And they are very, very, good. They are very, very efficient that way, right? Because you know what to expect from those health check. Even, the load balancer knows what to expect from the health check, right? So you have different types of load balancers, which we'll talk about in upcoming slides, right? So 4 kinds of load balancers that we have on AWS. You have the classic load balancer. You have the application load balancer, which is also called the elastic load balancer, right? All of them are called like the elastic load balancer service. But these ones are just, varying types. So you have the network load balancer, and you have the gateway load balancer, right? So I'll just talk briefly on some of this. The idea with mentioning this is just so you have, a good idea of what is available on there, right? You don't necessarily need to know all of them, how to configure all of them very deeply, right? Right now, you just need to know in which scenarios you would need them, right? So for the classic load balancer, it was the first version that was launched in 2009. So that's been a while now. It was 15 years ago. It provides basic load balancing across multiple EC2 instances. It operates at both the request and connection levels. So it supports HTTP, HTTPS, TCP, and SSL protocols, right? This load balancer, I believe, would soon be deprecated at some point. I believe AWS would soon remove it at some point because they keep warning that, it's old. Anything you see that is called classic on AWS, just know classic refers to being old or outdated or something that they plan to remove at some point, right? So we used to have classic EC2s then, but they're completely gone now. Now we just have EC2s, right? So that's it for the classic load balancer, right? The application load balancer is much newer. Was introduced in 2016. It operates at the application level. It's designed to handle traffic routing, to optimize traffic for HTTP and HTTPS. It also supports WebSockets, right, which is useful for real-time communication application. So application load balancer is the one you would most likely use in most scenarios on AWS. It's the one you most likely use because it has what modern day applications need, right? But there are alternatives, right, depending on what you want to do. So we also have the network load balancer. It was released in 2017. So network load balancer operates at the transport layer. If you're familiar with your OSI layer, if you've heard of that before, but that's fine. Also, if you haven't, but just know that it's designed for high throughput network traffic where performance is required. So if you have questions regarding high throughput network traffic, that means they are not particular about HTTP, HTTPS. They're just particular about network traffic. That's like TCP and TLS, UDP, right? You should be thinking of network load balancer. It's able to handle millions of requests per second while having very low latency. Right, then the last one you have is the gateway load balancer. This is much newer. It was launched in 2020. It operates at the network layer this time, right? It's designed to help users deploy and manage virtual appliances, things like firewalls, virtual firewalls, intrusion detection and prevention system. That's what you call your IDS or IPS virtual ones. Your packet inspection system. So those are more networking based appliances, right? So gateway load balancers help deploy those kind of things. So it works with the IP protocol, right? And it simplifies the architecture of these virtual appliances. Previously, deploying virtual appliances on AWS was like pre-2020. It was a hassle, but since this came, it's made it a whole lot easier, right? So these load balancers, they can be deployed in two ways, basically. Can either be private or public, right? Can either be internal or external, right? So internal load balancers route traffic within a VPC for applications that are supposed to be private. So internal load balancers don't respond to traffic from the internet. They respond to traffic that are local, that are just within that VPC, maybe one application speaking to another application, right? Let me give you a visual or a practical use of that to be a situation where, let's say you are running a private application that needs maybe like more than one EC2, and the traffic needs to be load balanced within them. Like maybe it's a banking application and your bank is connecting to it over VPN, right? So you use an internal load balancer. So you configure your VPN to be able to access that internal load balancer. So when the traffic comes in, it just hits the internal load balancer and load balances is across that are configured as the back end for that internal load balancer, right? So you can also, of course, deploy load balancers as external load balancers, public, right? Those are the internet-facing ones. So they route traffic from your internet to your servers, right? This is the typical situation that people would have, right? So you need to consider what you need, what your specific requirements are for your application, things like the protocol you're going to be using, the level of control you need, the performance requirements, whether your application is internal or internet facing or not. You need to consider all these things when you're choosing a load balancer. The automatic choice is not always, the automatic choice should not always be application load balancer. You need to know what exactly do I want to do, right? But I'll just say for most scenarios, people, for what they usually deploy, they would need the application load balancer. And these load balancers integrate with other applications within AWS, right? So that's a great thing, right? So we've spoken about load balancing. We spoke about high availability before. So you can't speak about load balancing without auto scaling, because if you think about it, load balancing ensures that traffic is distributed across servers, multiple servers at the back end, right? But it works best when there is the ability to automatically increase the number of servers and reduce the number of servers, right? So it works hand in hand with auto scaling, which is, the automatic version of the scalability we are talking about. So we'll just talk through what auto scaling is now, right? So auto scaling is just the ability for your servers to automatically, increase in number and reduce in number based on the actual load that you have, right? So AWS does this. There's an auto scaling service that when configured, you can tell it, at what point it should add a new server, at what point. And when I say at what point, I just mean the metrics. So you can say, oh, if the average CPU is 60%, add a new server. That means there's already too much load. if the average CPU is if the average CPU is 6% or higher, yes, add a new server. If the average CPU is 50% or lower, remove a server. That means, we are getting to low traffic, right? So those kind of things you configure ensures that it's able to automatically grow or automatically shrink, right? If I'm going to use an analogy for this, you can think of maybe the way Uber works, right? So if there's a surge in, let's say, you have a fleet of taxis like an Uber, right? That can grow or shrink based on the number of passengers that are needing rides, right? So if the demand increases, there will just be more taxis available on the Uber app. And if it decreases, the extra taxis goes away. I know that's not probably practically how Uber does it, but just think of that kind of situation where demand automatically increases the infrastructure, right? Well, this is not something you have to manually do, right? So auto scaling helps you maintain application availability and allows you to scale your EC2 capacity without manual intervention, right? Scale it down or up according to some conditions defined. Like I said, something like CPU utilization. Right, so it ensures that you have the right number of EC2s available to handle the load for your application at every point in time. So one interesting thing, auto scaling service, it allows you to set a maximum and a minimum, right? We'll talk about that more in the next slide. But for instance, you can say, oh, I want a minimum of 1 server running, and I want a maximum of 5, right? So even if you configure your auto scaling to scale in a way that responds to traffic, once it reaches that threshold of 5, it stops scaling up, right? It stops scaling up, and and that is important. You might think, oh, why? It should always continue. But there are situations, and I've seen these situations practically in my previous workplaces. There are situations where you have maybe malicious requests coming in, or hackers or bots or something that are sending a lot of traffic to your sites, right? And those traffic, might just be useless traffic, right? That they don't need anything from your site, you just want to bring it up. So you also want to reduce. So if you don't put a good limit on the number of servers it can scale to, you spend a lot of unnecessary money, because it can scale up to 50 servers, and you see that your AWS bill will be something else. And it's also good just in case somebody gets into your AWS environment and just causes some sort of auto scaling or something like that. It just ensures that you limit it and you don't have to pay unnecessary fees if it starts scaling up to 100 servers, that kind of thing, even though you didn't mean for it to do that, right? So minimum and maximum are always good. The minimum just speaks to the minimum amount of traffic you envisage. So if you envisage a traffic that needs a minimum of 1 server or 2 servers, you set that as your minimum, right? So it will always be running. If it's 2 servers, you set it to always be running 2 servers. It will never run 1 server. Even if it's scaling down, it will never scale below 1 server. It's below 2 servers rather, because that was your minimum, right? So the goal of auto scaling, like we've spoken about, is to scale out to match increased load. That's to add EC2 instances. To scale in, to remove EC2 instances, to match decreased load, to ensure that you have a minimum and a maximum number of instances running, to automatically register new instances to the load balancer. Now you see where the link up is coming now, right? Because when you add a new instance, the load balancer needs to know about it so that it can send traffic to it. So the auto scaling group, right? Which is part of the auto scaling service, right? The auto scaling group, I didn't talk about that, but it just speaks of a group of servers, right? It just speaks of a group of servers. It's more of a concept than a service. It's just a little feature within auto scaling, right? So you need to let the load balancer know that I've added a new server. Please send traffic to this server. right? So they work together. When you configure it, it just automatically knows. So it automatically registers that new instance, that new EC2 instance to the load balancer, right? So it also, the auto scaling group also lets you, it also recreates an EC2 instance if a previous one was terminated. For example, if it was unhealthy, right? So if you said, oh, I need minimum of 2 instances, right, running, you set a minimum of 2, and for some reason, one of the 2 gets terminated, even if it's you that goes and terminates it just to see what will happen, what will happen is it will automatically spin up another EC2 instance, right? But if it's a situation where, you know, it becomes unhealthy and it gets terminated, it will still spin up. It will ensure that it maintains what you have defined for that auto scaling group, right? So the auto scaling group, they are awesome for cost efficiency. They are really, really, you know, great for cost efficiency, right? The auto scaling groups, they don't have any cost on their own, right? The ASGs are free. You only pay for the services, the instances that are spun up, right? The EC2 instances, right? So they ensure that, I mean, when you need higher number of instances, you get it. But when you don't need those instances, they're not just running and costing you unnecessary money. So they reduce them automatically, right? So yes, so within the AWS architecture, auto scaling group is fundamental. You hardly see any AWS architecture that doesn't have an auto scaling group these days. It will always be there. So it just ensures that, you know, there's always the right amount of traffic at every point in time, right? So this is an example. This is just a visual, you know, display of what the auto scaling group looks like. Well, not the service itself, but like the minimum capacity I mentioned, the maximum capacity. Then there's something called desired capacity, right? I will explain that in a moment. Then this scale out as needed just speaks to the extra number of EC2 instances that were added. So to explain this, just think of this as, yes, of course, an auto scaling group, right? So the initial number of servers we started with based on this diagram, right, is 2 servers. That's the minimum capacity. So let's say we started our auto scaling group with 2 servers, right? And we designed it or configured it to have a maximum of 7 servers because this maximum capacity here is covering everything, right? So we have a minimum of 2 and a maximum of 7, right? So this desired capacity here just speaks of a situation where you have increased load. So desired capacity is the amount of servers that the auto scaling group believes that you should have at that point in time, which is what will be running, right? So if you know you have increased traffic, your desired capacity would increase, right? If you have increased traffic, let's say you have double the amount of traffic, your desired capacity might increase by something like 2 to 4, right? Because the auto scaling group is very smart. They can look at the traffic and determine, you know, based on the metrics you set in terms of the CPU utilization and determine how many servers you would need. Can do that math very quickly, right? So your desired capacity can also, you know, reduce if traffic reduces. So by default, when there is no, you know, change in traffic or whatever, your minimum capacity and desired capacity will be the same, right? Because you said you wanted 2 servers minimum, and there's no real, you know, traffic that is going to cause it to change, like to increase. So your desired capacity at that point will be 2. So, but as things change, as traffic comes in, you know, your desired capacity can increase. Now, another important thing to note is well, the first thing I just talked about is that auto scaling group can determine your desired capacity for you, but you yourself can set your desired capacity if you want. That's another option. Some people do it, some people don't, right? Depends on, your architecture. So in terms of setting your desired capacity, when you are configuring your auto scaling group, you set your minimum to 2 based on this diagram. You then set your desired capacity to 4. So what that means is you are telling the auto scaling group, ideally I want 4 servers, right? But if at any point, based on the traffic, you see that 4 servers is not the best, then take it to the minimum, right? But if not, just leave it at 4 servers, right? That's your desired capacity, right? That's why I say most people don't set desired capacity, they allow the auto scaling group to figure it out. But sometimes, you might just want to manually change it, because maybe you need more, you're foreseeing some traffic coming in, so you just change it. So if your desired capacity was 2 before and you change it to 4, immediately the auto scaling group reacts because it wants to always match your configuration. So once you say, I want 4, it will automatically add 2 new servers to match your configuration to ensure that it's giving you what you want, right? So this scale out as needed part, which is the last part we haven't talked about, is just speaking to, again, increased traffic, right? That might require it to add 3 more servers, right? So this is just a diagram to just show what that increase can look like. Now, this is the traffic flow in AWS for auto scaling using an elastic load balancer, right? So you would have traffic coming in from your users here to the elastic load balancer. And the elastic load balancer would do health checks on each of these consistently. But when that traffic comes in, to send that traffic to each of them, it will distribute it to each of them to ensure that, there's a smooth experience for the users. None of the servers get overwhelmed, right, with the load. So it's possible for you to scale an auto scaling group based on things like CPU, like I mentioned, but you can also scale auto scaling groups based on CloudWatch alarms. I know we haven't talked about CloudWatch alarms so much yet, but CloudWatch alarms are just, we've talked about CloudWatch, but maybe not the alarms. They're just monitoring tools that you can configure to say if, if a certain resource utilization goes above a certain threshold or below it, just send me an alarm, right? So you can say, oh, if the memory is above 90%, send me an alarm. If it's CPU is above 70%, send me an alarm. So those kind of things, right? So usually people would use CloudWatch alarms also to scale auto scaling groups, right? So you can create something called a scale out policy and a scaling policy, right? Within auto scaling groups, scale out policies are just, don't mind the name. It's the same thing we've been talking about. It's just a configuration that says this is these are the conditions that need to be fulfilled for you to add new servers, new instances to the auto scaling group. And scaling policies just says these are the conditions that need to be fulfilled for you to reduce the number of instances, right? But those are the technical names that they are called, scale out and scaling policies. So in this diagram, it just shows that a CloudWatch alarm can trigger, scale out or scaling, right? Because the CloudWatch alarm is just checking to see if the average CPU across all the instances is an example. Across all the instances are, at a certain level. If they cross a certain level, that means there's too much load, so we need more servers. If they go below a certain level, that means there is too little load, and we don't need as much servers as we have. So let's reduce those number of servers, right? So I hope this concepts make some sort of sense, like draw a picture in your mind, and you're able to kind of get where they come in within the DevOps culture and all that. So I'll just pause here. We have about 2 more slides before we round up. I'll also pause here just to get some questions. I don't see any questions in the chat, but we'd just love to get any questions, maybe something I explained you didn't understand, or something I didn't explain that you need me to clarify. So Bolaji has a question. Please, if you also have a question, just raise up your hand. Can go on, Bolaji.
Thank you very much. Please, now I want to, because I don't, maybe I always check myself. I don't like going with a wrong impression, kind of. So please, when you were teaching us about load balancing, now load balancing is the concept. It's like is the concept. Now there are so many things you can desire to load balance.
Yeah.
Network, application, because when you were talking about the network, you said the layer 3 of the OSI model.
Yeah.
Now application is layer 7. So like if I send in, I want to visit a website, and that's like more like an application kind of. So if I send in a request, that does not have anything to do with the network. It has to do with maybe the server where the application is hosted. Then, but when can you explain the network side of it? How does I know that in a way in Cisco there is load balancing when it comes to the router, the switches, somehow the network but I think you get my question.
Yes.
Then the second question I have is, you said when a server gets to like 60%, there will be like a nudge to scale up the server. Now, when another instance comes, who does the configuration of the new instance, or does it just clone all the things in the new server that comes up? Like I have server 1, and now have to have server 2. Is it someone that will configure the server 2, or the server 2 that is coming on board will just inherit all the properties or all the functionalities or whatever of the existing server? Thank you.
That's a great question. Thanks for those questions. I would touch on both of them very briefly. So the first one, I think what you need to keep in mind is the load balancing is not speaking to how the users access the sites, but it's speaking to how the load balancer load balances traffic across the instances at the back end, no matter what those instances are, be it EC tools or let's say databases or whatever they are, maybe virtual appliances, right? So when I was talking about application load balancer, right? So application load balancer is designed to handle advanced traffic routing. So it can do its own load balancing, at that HTTPS level, right? It can balance traffic maybe based on some sort of traffic routing that you determine. So you say, okay, let me see if I can give an example, right? So you want to say, load balancer, this is what I want you to do. I want you to give, so I want you to balance 30% of the requests, on the balance traffic coming to a certain, part of my website to 30% of the servers. Then I want you to, distribute the rest of the traffic to 70% of the servers. I don't know if you get what I mean. So let's say you have a website let's say www.jumia.com, and you have a part of the site, maybe www.jumia.com/Black Friday, then you have like www.jumia.com/December sales. Just a hypothetical situation, right? And let's say you're in Black Friday season, but December is coming, but you are in Black Friday season. So you believe that there is more traffic that will be coming for, Black Friday, right? So on application load balancer, you have the ability to route more traffic to servers, right? On that, more traffic coming to that Black Friday URL or that Black Friday part on the website to your servers than what's it called now, the December sales one. So it's able to work on that HTTPS level, right? It's able to do so many things in terms of it can. Application load balancer can even say, okay, if traffic has a certain if it's coming from a certain IP address, or if it's coming from a certain, there's something they call host header, right? Let's say maybe you're accessing, maybe you clicked a link from site A and you're going to site B. So you say, okay, check, this person coming from site A, then route the person to this server, don't route them to this server, right? So that load balancing is even just beyond ensuring that, the servers are not overwhelmed. Yes, that's a primary responsibility, but it has advanced features that enable you to do different routing just based on how, your site configuration is. But something like network load balancer now that functions at the transport layer, it cannot do that. It can only do TCP, kind of load balancing. So at the back end, so one thing to also remember, right, is when I'm talking about load balancing at the back end is those different protocols I'm speaking to, how it talks to the servers, right? So for network load balancer, it speaks to the servers via TCP, TLS, UDP, right? Those are protocols. For anybody that doesn't know that, you don't necessarily need to know that, but you can just read up about it, right? Those are different networking protocols. But for the application load balancer, it speaks to the servers over HTTP or HTTPS, right? So again, it depends. Your application, for instance, at the back end, might only might not support TCP or TLS for that communication. It might only support HTTPS, right? So that determines your choice. So it's not really that network load balancer is better than application load balancer. It just depends on what you want to do, right? I hope that clears that up, but if it doesn't, you can still let me know. But to your second question, yes, you were asking if the servers, how they get set up, right? So that's something we didn't talk about, but typically you would configure the servers in the auto scaling group to ensure that when the auto scaling group brings up the server, it is automatically configured, right? That's one way. And when I say automatically configured, actually that can mean two things. The first thing is some people use what they call images, right? On AWS, it's called Amazon Machine Image. They would have pre-configured a particular server to make sure that they will install everything that it needs. Then they will create an image of that server, right? An image is just like a template that you can use to run a server and it have everything that it needs. So they will now configure the auto scaling group to spin up servers using that image so that every time a new server comes up, it has everything that it needs already. That's one way. Another way is for them to write scripts, maybe even bash scripts, and configure those scripts to run on startup for that server. So as soon as the new server starts up, the scripts run and install everything that is needed. That's another way people do it. So to your question, yes, there is a way to ensure that those servers have everything. It's not automatic. You actually have to configure them But we're not going too deeply into that. That's why we didn't talk about like how to configure all those. This is talking more to the concept of how auto scaling works and the like. So I hope that answers your 2 questions.
Thank
but
you
if there's anyone,
much. It does.
oh,
Yeah.
okay,
Thank
all
you.
right,
I'm grateful.
all right, awesome. You're welcome. You're welcome. All right. Please, do we have any other questions? I know some of us have some questions that we would like to ask to just clarify. And I mean, even if you think, you have a question that might be drawing us back to something we talked about earlier today, that's fine. Like it's still all right. We can answer it. What's, I just want to achieve is to ensure that everybody has a good understanding of what's happening, so that even when you go back and you read up on the slides, you watch the video again, it will just really, cement anything that has been learned. So I'll give a few minutes. Please, if you have a question or a comment, or just a confirmation, let me know by raising up your hand. All right. Okay. So it seems like we're really taking it in. I hope that's the case. I hope we're not hiding our questions. I hope no one feels, uncomfortable asking a question. If you don't want to speak, you can just put it in the chat also, and I'll talk about it, right? But to save on our time, I'll just move on if there's no question right now. All right. So one of the last things we have to talk about within this AWS Solutions Architect track here is Amazon RDS. Amazon RDS. And this is the database service, or one of the database services for AWS, right? But this is the relational database service for AWS, right? It simplifies, it's a service that just simplifies the setup, the operation and scaling of a relational database in AWS. Relational databases just speak to databases, things like MySQL, Postgres, all this Microsoft SQL Server, this kind of servers that require information to be stored relationally within the server. That means storing relationally just means that you have to have, predefined the different what they call it, tables that you want in that database, right? You say, oh, this table should have this columns and all those kind of things, right? You want it to have a user ID, you want it to have a username, a password, whatever, as opposed to what is called NoSQL, which we won't be talking about because that's not really in scope. But things like NoSQL allow you to, just not define those like your database schema, define those tables, but you can just define them on the fly as your data comes in, right? So for RDS, yeah, it's a managed service on AWS. It's not like situations where you maybe host your database on an EC2 or on some other server where you have to be managing it and be doing updates and be doing configuring replication manually or those kind of things, right? It's a managed service. It takes away much of the heavy lifting of database administration, right? In the older days when this service didn't exist, you need a proper database administrator to be able to set up and operate a relational database, something like MySQL or Microsoft SQL likes, right? So as you see on the screen, it supports more different types of relational databases, Postgres, Postgres SQL, MySQL, MariaDB, Oracle DB, Microsoft SQL, and something called Amazon Aurora. Amazon Aurora, and I'll talk a bit on that. Amazon Aurora is just is AWS's proprietary database engine. So it's something they created themselves and made it compatible with MySQL and PostgreSQL, right? So they designed it for high performance and high availability, right? Amazon Aurora has the ability to auto scale also. Auto scale storage, auto scale the number of database instances. So it does its own load balancing internally. You don't even see that configuration. So it's a very amazing service, actually. Amazon Aurora. It's a very amazing service in that it just makes database management very, very simple. And the performance is very good also, right? So RDS is designed to to integrate seamlessly with other AWS services, right? So it just makes it easy to set up the data layer of your application stack within AWS. So we're talking about EC2s, right? But you always need a database most times. So Amazon RDS ensures that that is very easy for you to set up, right? It also, I guess it's good to mention, it also has like great monitoring capabilities, right? It has good metrics, comprehensive metrics that you can use to know if something is wrong with your server, or if your server needs more resources or needs less resources, and all those kind of things. So its ability to be scalable, to be highly performant, and to be highly available also, because I think I mentioned that a few slides ago, that Amazon RDS has the ability, or it gives you the option of deploying your databases across multiple availability zones, right? So you can have Amazon RDS deploy your database in a way that it's available across even up to 3 availability zones. It's called a multi-AZ deployment. In that situation, you don't set up replication, it sets everything up for you. Basically, all you need to do is just configure it once, and it does everything at the background, right? Which is why I say it's an amazing service, because if you do this with, if you do this yourself, it's going to be very difficult to achieve that, right? You need to be a database expert to set all that, but RDS, specifically Aurora is there to make that happen. So that's basically what RDS is. Complements EC2s, and it's needed, in the DevOps space, of course, because you always need to store data somewhere, right? So the last thing we're going to talk about for today is a very interesting topic called, or subtopic, let me say, well-architected framework. Well-architected framework, right? So well-architected framework, or AWS well-architected framework specifically, is something that AWS created to help developers, to help architects, DevOps engineers like you to build secure, high-performing, resilient, and efficient infrastructure for your applications, right? So it's this kind of thing where AWS looked at their experience based on working with infrastructure for so many years, and they were like, okay, let's design some sort of best practices for people to, or some framework, a guide for people to be able to follow, so that they can have like the best performing, infrastructure on the cloud, the most secure infrastructure on the cloud, the most efficient infrastructure on the cloud. So this is kind of a suggestion from them to you to say, if you're going to build your infrastructure, follow this framework. Like, make sure that these different things, like the 6 pillars, make sure that they are implemented on your application. And we're going to talk about what each of them mean and what they look like practically, right? So we have the 6 pillars, like I mentioned. We have operational efficiency. We have performance efficiency, right? Sorry, operational excellence, not efficiency. Beg your pardon. We have operational excellence, performance efficiency, reliability, sustainability, security, and cost optimization. And if you look at this, just even generically, this is something that every company is usually trying to achieve. But they might not, have just written it down in this way. Everybody wants to optimize cost. Everybody wants to be secure. Everybody wants to be sustainable. Well, maybe not everybody, but most people. Everybody wants their application to be reliable. They want it to be efficiently performing. They want it to operate excellently, right? So, but within AWS, operational excellence speaks to running and monitoring your servers to deliver business value. And it speaks to continually improving processes and procedures, right? So in terms of operational excellence, you want to ensure that you have good monitoring set up to be able to know if your servers are running, efficiently. All right. To be able to know if your servers are, if you're able to, if your servers are reporting some indication of issues in the future, right? There are some times where your metrics can tell you that, oh, this server is going to have issues in the future or something like that, right? So your ability to continually monitor the servers to deliver business value, right? And to continually improve your processes. So one of the things you do in operational excellence is to ensure that you are, checking out how well your processes are running, right? Things like, so in operational excellence, you want to, rather than do manual changes, you want to do automated changes, right? You want to not always have to click things. You want to automate some things, write scripts for them so that you avoid human error. So that speaks to operational excellence. For instance, trying to avoid human error when you do things, right? Operational excellence speaks to responding to events. So if, for instance, AWS tells you that, one of your servers is having an issue, right? Operational excellence says you're going to respond to it immediately and not just, ignore it, right? So it just speaks to how you operate your system in a way where it continues to deliver business value, right? And you try to improve every process that you have. Let's even give an example of that improvement. So, for instance, in my company, we do things called disaster recovery. Right? Yes, business continuity and disaster recovery. That one just speaks to, oh, you are trying to test if your process for recovering from a disaster on AWS works. That's operational excellence, right? So for AWS, if you're going to pass that pillar, you have to have a process that states out how you would perform that disaster recovery, right? Processes and procedures, you have to have them documented. Let me give one more example. In a situation where, okay, so something AWS will expect you to have in this operational excellence pillar is a procedure to respond to an incident where the root account credentials have been leaked, like the root accounts for your AWS account, right? Let's say, it's a big company, somehow the root account got leaked and someone has access to it. How do you respond? If you are going to pass this pillar and follow their best practice says have a document that, it shows the process of what exactly you would do in that situation, right? So that is it for operational excellence. So performance efficiency. This pillar focuses on using IT and computing resources to meet system requirements and maintaining that efficiency as demands changes and technologies evolve, right? So performance efficiency just speaks to selecting the right resource types, the right sizes. So you shouldn't be using, something too big or something too small. So efficiency speaks about just using right about enough of what you need. right? So you shouldn't be using an overly large server when you have very low traffic, and too small of a server when you have constantly high traffic. So it speaks about monitoring performance and making informed decisions, right? So yeah, in this case, you are monitoring just like in operational excellence, but you are not monitoring necessarily to respond to problems, but you are monitoring to look at those metrics and make informed decisions whether things need to change for the long term, right? Hence, you're able to maintain the efficiency, as your business needs evolve, right? So if you are looking at the fact that, oh, we run at 60% CPU most of the time, and we have like a constant level of traffic, and there's a new business need to add a new service under your application, and that new service will bring in under 1,000 customers, right? You monitor what you have, you make an informed decision. Okay, based on the monitoring metrics we have, I believe this is the number of servers we should add to meet these new business needs, right? So that's performance efficiency, right? So the next one is reliability, right? So reliability ensures that it ensures the ability of a system to recover from infrastructure or service disruptions, right? Dynamically acquiring computer resources and mitigating disruptions. So this involves having the high availability we spoke about. That's part of this. This involves having a disaster recovery plan, like I said. In this case, operational excellence speaks to, that I mentioned before, speaks to you know writing out that process, but reliability is speaking to you actually testing out that process. It's not just writing it out. Reliability is saying, oh, I have a recovery plan. If something goes wrong, I know what I'm going to do, right? But in cases of high availability, you already have like an automatic recovery plan, because you know that if one server goes down, another one is still available. So reliability is just your ability to recover from infrastructure failures or service disruption. So you design your infrastructure to be able to recover for that. So if you do that, based on how AWS suggests, then you are covering that reliability pillar. So sustainability speaks more of the environment impact of running cloud-based applications, right? So it involves you it involves you designing infrastructure that maximizes performance while minimizing energy consumption and your carbon footprints, right? So if you are well read up on sustainability, you know that every company is trying to reduce their carbon footprints, just the amount of fossil fuel that is being burnt or being used, right? And they're looking for more sustainable ways to run their infrastructure, right? So AWS has certain instance types that are more sustainable than the others. An example is like if you are running a server that is too large, like you need only 2 GB in reality, but you're running something like of 16 GB, right? That is not a sustainable approach in the sense that you're using more resources than you need. So you're basically burning more, you're increasing your carbon footprint, burning more fossil fuels than you should, right? So the sustainability pillar speaks to using minimizing your usage to ensure that like you reduce your carbon footprints, right? It also speaks to utilizing serverless infrastructure, right? Serverless architecture. We've not really talked about that because that's like in the more advanced tier, but yeah, serverless architecture in the sense that, you don't have to run servers. AWS just manages everything for you and they know how to make it sustainable in their end, right? The second to the last pillar is the security pillar. I think it's self-explanatory. It just speaks to protecting your information, and your systems, right? Controlling access, responding quickly to security events and the like. So you, in that case, you will ensure that there's a level of security monitoring, there's a level of traceability. That means in the security pillar, you should be able to know who logged in at what time to anything, right? Who created the server, who ran this thing. So in that traceability, you're able to know what those logs are, right? And what those actions are. So in that case, it ensures data protection, and the likes, right? So security just focuses on you being able to track the security events on your system, you being able to respond to those events, you being able to protect your systems, right? Control access. I know we talked about, what's it called now? Principle of least privilege access. Yes, I believe that's, you feel that security pillar, right? Because the focus is on security, having exactly what you need. So the last one is the cost optimization pillar. So cost optimization just speaks to avoiding unnecessary costs, right, and getting the most out of the resources you invest in. So it involves understanding where your money is being spent, right? So AWS has some services on the platform where you can see what, what services are costing you, more. For instance, on the platform, if you spend $20 last month, even if you're in the middle of the month, they can do some sort of estimation to tell you, oh, you're about to spend 50% more than last month. And if you didn't change anything, cost optimization will say, let me go in and look into that and see why my cost is increasing, even though I've not done anything, right? So it ensures that you are controlling where your money is being spent, right? Optimizing, getting the best out of your resources, selecting the most appropriate and the right number of resource types that you need, and just analyzing how much you spend over time, ensuring that your business needs are being met without overspending, right? Even though AWS, want you to spend money on their platform, of course, but they would not want you to overspend like what you don't need. There's no need of spending that, right? So these are the 6 pillars, right? This is just, there are more practical ways that these things play out, but this is the general concept of what they represent and why they exist, right? So the framework's purpose is to provide a consistent approach to evaluating architectures and implementing designs that will scale over time. So they created this framework for you to, like as a customer, you take it, then you go and look at, use it to review your own workload, use it to review your own architecture in your company and say, okay, are we passing these pillars, right? And they actually have like a document on their site. If you go and check it, like there's a more defined, like a more detailed rather description of what each of these things mean, what the requirements are for you to pass these pillars, right? These best practices. There's actually what they call, so it's kind of like a certification they do for companies where you can enroll for them to, review your architecture to see if it's well architected. And if you pass, right, if your architecture pass, they will now certify you to say, oh, this company's architecture is well architected, right? I know in my company, we ran through that about close to 2 years ago. And it took us maybe about 3 months to pass all these pillars, because there are certain things you have to do. Like I said, for instance, you don't give people too much access. We have to restrict everything. We have to review all our logs and monitoring. So these are things, this framework is something they provide for you to take and go and review against your own workload, and know how you need to improve your architecture. So as a DevOps engineer, it's very critical for you to understand, how all of these things play out, to understand the concept, to ensure that you're always creating, efficient, secure, reliable cloud infrastructure, right?
Sorry,
And this is
Wisdom.
going to
Can I
be
quickly jump in?
okay. Sure.
All right. Apologies, guys. I'm just jumping into this call from a different class, and I'm going to be jumping out quickly again. But the reason why I have joined is because last week there was a slide that Wisdom was taking that I said we need to correct because I felt it was wrong. But I'm wrong because it was actually correct, because myself and Wisdom talked about it afterwards, and I had a different opinion and he had a different opinion. And I think what he's saying is correct, right? So I'm going to jump out now. So if you can just please go back to that slide and quickly talk about it again, so that we're all on the same page, so that if there's any misconception that the learners have, we can try to get that out of the way. So I just wanted to quickly come and highlight that, so that the understanding is the same for everyone.
Sure.
All right, thanks.
Yeah, thank you so much. Yeah,
Cheers.
I'll talk
Bye.
about that. Yeah. All right. Okay. So we're done on the well-architected framework, but let me just touch on that slide. It's actually just one sentence. So it doesn't really disrupt what we're doing now. So it is, just give me a second. Yeah, so it is this sentence here where it says, the NAT gateway can't be used by an EC2 instance in the same subnets, right? Only other subnets. So this is actually correct, like you mentioned. And I know we've already been in a mind of auto-scaling load balancer, so I don't want to drag us back to this, but I just want to say, if you go and read this back, just know that like everything on this slide is correct, right? So I'll just leave it at that, because I know we've actually gone through quite a number of things, right? So for the well-architected framework, I don't know if we have any questions, right? What I just talked about in the well-architected framework, RDS. Yeah, it was just RDS and well-architected framework. We're rounding up now. That was the last slide. So please, if you have any questions based on what we just spoke about, let me know. Or anything we've talked about within the last 2 hours. Okay, we still have about 8 minutes. Okay, Chike has a question. Please go on, Chike. Okay. All right. You can put your question in the chat and I'll put it before we go. But do we have any other questions from anyone? We round up. It seems like we don't, and it's just Chike. Chike, please let us know in the chat if you're typing. Okay. Oyadeni said, need to read up, but all good so far. Right. Please do. Just cement your understanding. One class like this wouldn't be sufficient to, help you understand everything you need to, but I believe it goes like 7% of the way, gives you a good foundation to work off of. And, your further reading and the project would cement it. So we'll just wait on Chike's question and we'll answer that and wrap up for the day. Chike, just to confirm if you're still typing, maybe it's a long question. Wonderful. All right, it has been a while since my last class, and to be honest, I've not had time to go. The classes have missed my questions. It seems to me like most of the AWS activities happen in the GUI. So the thing with AWS is you can choose to do your activities on the GUI. You can choose to do them on the command line, right? Or even via the API. in whatever programming language you want. But of course, for beginners, we want you to start from the GUI, right? So you have a visual understanding of what's going on. If you just go straight to the command line, trust me, everything is gonna be a bit harder, right? So you start from the GUI, just understand how that works. Then you'll be able to replicate that same thing on the command line, right? So yes, both options are available. Both options are available. Stephen said, I was thinking like our usual practice, some of all the things you mentioned will be practicalized on AWS. Yes. So the thing about this is some of these topics, the topics we talked about today, they're unique in the sense that they are more conceptual, right? In order for us to do them practically, it would take the whole of the class, even just to, go through like auto scaling and the likes. You will trust me, it will take the whole of the class. So we can't do those kind of demos within just to ensure that we can cover the whole concepts that we want to talk about. But those are things that, would be covered in your practical projects, right? So you're able to get steps to do those things, as you need to, right? So that's just the reason. And that's a good observation that you made there. But there's a reason for that. It's just because, we're talking about concepts and how they link up. That's why we just had diagrams and the like, so that just gives you a conceptual understanding. Okay, this is what exists, this is why it exists, and all that. So whenever you get into the GUI or you work on a project, you're able to just match that together with the actual technical work that's been done. Right? So I hope that clears things up. All right, so if we don't have any questions, I would like to thank you guys for coming through again. I hope the class has been very useful. I hope you've gotten learned new things, right? Which is what is most important, learning new things. I'll just encourage you, to continue to read beyond this class, right? Read deeper into all the things. Everything that we need to learn cannot be crammed. Yes. So Stephen said it sticks better when you practicalize it. Yeah. Yeah. So that's what I'll say. Try to practicalize them, right? We have, those practical sessions the practical projects, right? So within your learning activities. Serial, so GUI means graphical user interface, right? So GUI is just what you can see on your browser, like what you click and all that. All right, so sorry. I think Teams kicked me out for some reason. Maybe it was the network. All right, so but we're rounding up. I think I've covered most of the questions. If you didn't hear me before, Cyril, I was just saying GUI just speaks to what you can see on your browser, on your laptop, like what you can interact with your mouse and the like. Yeah, the graphical user interface, right? The alternative to that is the CLI. Oh, okay, you also lost network. Okay. The alternative to that is the CLI, where you just, type commands and all that. GUI, you can do clicks and, even drag to what you want to do, but CLI, you are limited to the option of just typing your commands and running what you want to run, right? So just not to overshoot this class, thank you so much, everyone, for joining in. We'll see you guys again next week. Please do read up, please do practice, and come with your questions if you have any. You can follow up for the slides. I'm sure someone will send that right on your Slack, and you can ask any questions you have over there. So thank you again. Have a good evening. See you next week.